Okay, folks, this video is going to cover the middle portion of your notes over mean, median, mode, and range. It will discuss the visual representations of this data, and it will discuss what you can and cannot find from these sets of data. Now, when we display data, there are several different visual ways that it can be represented. We could use a dot plot, a histogram, a frequency table, a bar and whisker plot, stem and leaf plot. There's a lot of different visual representations that we could see. So we're going to talk about several of those in this video, not all, but several of those, and what we can and cannot do with them based on the idea of prepping for the SAT. So here we have a dot plot showing the heights of a total of 9 giraffes, and the way we know there's 9 giraffes is there are 9 dots, which means we're looking at the height of 9 giraffes total. So when we go to do the mean, we would add up the heights of these giraffes. Well, that's 2 14s, 3 15s, 2 16s, and 2 18s. Okay, so we'd add all of those up. So we're going to take out our calculator here, and we are going to add up those heights. Give me a second to make sure I don't screw that number up. That is a total of 141. Then we are going to divide that by the total number of giraffes, which is 9, to get 15.6 repeating, or about 15.67 feet for the mean of the giraffe heights. The median, what we can do is we can either rewrite the data set as numbers or just use the dots themselves, which are already in order, to find the middle number. Okay, if we look at this and we work our way in from the outside, we discover that there are actually only one number in the middle, and that is 15. So our median is 15 feet. Mode, there are 3 15s, which means that our mode is 15 feet as well. And our range is the biggest, 18, minus the smallest, 14, or 4 feet. So a dot plot is just a way to visually represent the data. It is very easy to calculate the mean, the median, the mode, and the range from that. Okay, our next visual display here is a box plot, also known as a box and whisker plot. Now these are more commonly seen in your AP statistics courses, as they shows the 5-number summary of the data set. As a result, you cannot use this to find all 4 values. You can only find 2 of those 4 values from a box plot, from a box and whisker plot, which means on the SAT, they would not give you a box and whisker plot and ask you to find something that you're not capable of finding. Okay, here we do not know what the individual numbers in the data set are. Therefore, we cannot figure the mean. Okay, with a box plot, we are not able to find the mean. That is not possible. It's the same with the mode. If we don't know what the actual data set is, we are not able to find the mean or the mode. Okay? The other 2, however, we can find, and that's because of what these dots are telling us. This is telling us that our minimum value, the left endpoint, is 72. And this dot is telling us that our maximum value is 88, which means our range is 88 minus 72, or 16. The outside and insides of the boxes, the left and right ends of the boxes, these are called your quartiles, and that is not important to the SAT. That is a statistics idea. The lower quartile is shown at the left end of the box, and the upper quartile shown at the right end of the box. Since that does not apply to this course, Algebra 2, we are going to skip over that and leave it for your statistics teacher to explain. This line in the middle of the box is displaying the median of this data set, which is being shown as, I've got to think this line here is 80. That line is halfway between these two lines, 78 and 80, which means our median is 79. So we can use a box and whisker plot to very quickly find the median and the range. If you were to see a box and whisker plot on the SAT, those would be the only two items they would be asking about, either the median or the range. Our third and final display for this video is called a frequency table. And these can be very tricky. We need to know what the word frequency means. Basically, this is saying how many times that number occurs in our data set. So we have in our data set, here's what it looks like if we write it out instead of abbreviating it with this table. We have 3 ones, so 1, 1, 1. We have 8 twos, 2, 2, 2, 2, 2, 2, 2, 2. We have 4 threes, 3, 3, 3, 3, and 1, 4. So there is our data set written out as individual numbers. Our mean, what we can do is we can multiply these across and then add to get our total. Okay? So our mean, we can do 1 times 3, because there's 3 ones, 1 times 3, plus 2 times 8, there are 8 twos. There are 4 threes, so 4 times 3. And there is 1, 4. And then we divide that by the total of the frequency column. Add these up. That is 16 total numbers in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, we're going to use our calculator to figure the mean. We're going to figure out what we've got there. The top number would be 35 divided by 16, which is 2.1875, and that is where that decimal terminates, so there is no reason to round. Now, as for your median, this should take you 0 seconds when you look at this data set. If there are 16 numbers and 8 of them are twos, as long as there are not, more numbers down here, more numbers up here, the middle number is going to be somewhere in these 8 twos. But again, you've got it written out right here. You could count in from the outside. The median occurs between these two numbers. So it's really 2 plus 2 divided by 2, because we're supposed to average those middle numbers. But again, that is going to be 2. We should know that without too much effort. Frequency tables are extremely easy to find the mode. Whichever number has the largest frequency, that'd be this one, would be your mode. This is the most frequent, so this is your mode. Over here is 2. And finally, your range. Well, that's pretty easy as well. The biggest value is 4, the smallest is 1. We subtract and we get a range of 3. So that's some work with our visual representations. There is an additional visual representation we did not talk about called the histogram. Histograms have the same problem that box plots do. You cannot find everything from a histogram. It is usually possible to find a range of values on a histogram, but it is not always possible to find the mean, median, mode, and range with a histogram. That is why we did not discuss it in this video. Thank you very much for your time and attention.